Good morning, students. Hello. Good morning, students. Am I audible to all of you?
So,
Huh? Am I audible to all of you?
sir.
Can you start? Yeah. Can you start? So let's start, right? Hello. 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 Yeah. Good morning. Okay, students. Yeah. Thank you, Akidul. Thank you so much for wishing me. Yeah. So yesterday, Kabam. Kabam is there today. Kabam Maro. Hello. Kabam, are you there?
Yes, sir. Yes, sir.
Yesterday you asked me for some doubts, na?
Yeah.
Uh, so what we can do is look. uh, in the yesterday's class, you asked me regarding that diagram, right?
Yes, yes.
What was the doubt?
How F is equal to mg cos theta from past figure?
Uh huh. How is the figures different?
How F is equal to mg cos mg sin theta?
Look. Hmm. I'm sharing this. Okay. So look at this diagram. Hmm. So here it is an inclined one, right? So here it is an inclined one, and if you see the other diagram, if you see the other diagram, this is a straight one. As simple. This is as simple as, like, look, this surface is there. So sorry. These are the two surfaces. This one is one surface, and here This is the surface. So if you consider this as horizontal, it will look like this, na? Yes or no? It will look like this.
Yes, sir.
So definitely, definitely this. You said that the equations came from this figure, right? Yes or no?
Yes, sir.
Uh,
Yes, sir.
yeah,
Angle of
it
repose.
came from this figure, but this is the first illustration of this. But then for simplified thing only, we have drawn it in horizontal manner. But at the end of the day, the equations came from equations are from this only. But then we have interpreted in that
Mm.
figure. Okay,
Yes, sir.
okay. So the equations are from this only, but
Yes,
we
sir.
have interpreted in the from that figure. Okay. So you have to find
Okay.
or tally both the figures, and then only you come to the equations. Okay.
Yes, yes.
Okay. So we'll start a new topic today. So today we'll be starting the topic which is named as truss or plain truss. Do you know what is a truss? Any idea? Any idea? Do you know what is a truss?
No, sir.
Okay. Truss is a rigid structure. Hmm. Truss is a rigid structure which is in the form of a frame. Hmm. Now, do you have any idea what is a frame? What kind of frame it may be? Do you have any idea what a frame might be?
Window frame, photo
No,
frame.
no, no, not those frames. I'm telling you now. Wait. So basically, a truss. Suppose you have seen Assam type of houses. Do you know what is an Assam type house? Do you know what is an Assam type house? Students?
Yes, sir.
So the house
Yes.
doesn't have a concrete slab roof, right? That is known as an Assam type house. Yes or no? So now in Assam type houses, what happens? When you have the roof, that roof is attached to a frame, right? The roof is attached to a frame. The frame is a sort of combination of large number of triangles. Yes or no? Yes or no? Wait, I'm showing you a presentation now. Look at this. Hello, 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 students.
We are watching.
Yeah. So look at this. Now here there are large number of frames, right? This roof support, then this crane, then this electric tower, and this bridge. Yes or no? Or suppose this is the first basic definition. So what is truss? Truss is a framework. Truss is a framework composed of members joined at their ends to form a rigid structure. If you see here, these are what? These are certain frames, no? Yes or no? Yes or no? So these frames, if these are
Yes, sir.
joined together, then they are forming a rigid structure. These frames are joined together, then they are forming a rigid structure. This kind of rigid structures are known as truss. Have you seen this kind of things? Just look at it. Try to imagine. Have you seen this
Yes,
kind of
sir.
frames? These are very much prevalent in civil engineering works, right? So this kind of frames are known as trusses. Okay, is it clear now? Is it clear now?
Sir. Yes,
Hmm?
sir.
This kind of
Yes,
frames,
sir. It's
these kind
clear.
of frames are known as trusses. They are joined on their end to end. Okay, this one, this one, this one. It is joining here. Then these are all giving cross beams. Okay, so these are called these cross things. Okay, these cross things are called cross beams, and this one is called stringer. So if you see here, this main part is known as stringer, and this this are called what? Cross beams. Okay, so after that, if you see here, suppose, so here also these are floor beams. Why floor beams? Because we will put the floor panels here, right? Then only cars can travel over this truss. Have you seen this kind of bridges? Have you seen this kind of bridges? Mostly in railway constructions.
Yes, sir.
So this kind of,
All the time.
huh? What you say, Temazar?
Yes, sir. We have seen all the time, sir.
Yeah. So this kind of bridges are known as what? Truss bridges, or these figures are known as simply truss. Okay. So in this way, these are known as trusses. Now coming to the next one. Look, here are certain application of trusses. Ah, now in application, like in practical field where trusses will be used or it will be relevant. Can you say where trusses will be used or it is common? First of all, in roof support. Suppose I told you no very first example. Suppose this is an roof. Now here to support this thing, you have to put certain trusses so that they can be supported. Right. So these are known as trusses. Huh. Now, if you see in a bridge, just now we discussed, right? The edges of the bridge are truss. Now, in electric tower, this kind of towers is very common for transmitting high capacity power. So, what happens? So, these are also basically trusses, right? And similarly, large size cranes, these are also basically trusses. So, these are the example of truss. Now, suppose there are different types. So, what are the types? First of all, plain truss. So we'll discuss the types in detail. Okay. So these are the trusses that are plain truss. So plain trusses, they are Number one, bridge trusses, and number two, roof truss. So in bridge, the trusses are looking in this manner. They are Pratt, Howe, Warren, Kay, and Baltimore. Okay. Now these kind of bridge trusses are present. Look, this is the two support of a bridge, and the trusses are designed in this format. So this is how the bridge trusses look. Similarly, for roof, there are Pratt, Howe, Warren, and Fink. Okay, so these are the trusses for roofs. Then we have space trusses. Okay, we will eventually discuss this. Shall I go to the next slide?
Yes,
Yes,
sir.
sir.
So these are the analysis of trusses. This is, we will have to then learn some simple application of trusses. Okay. So here is the two differences between truss and frames. So trusses are stationary, fully constrained structures in which members are acted upon by two equal and opposite forces, and frames are stationary, fully constrained structures in which at least one member acted upon by three or more forces. So these are the differences. Okay, so I just explained you about the process. Now, can everyone say like yesterday? Sir, you are not showing any slides. Wait a minute. I was showing slides, right? And please do not give the attendance now. Just coming to the class and giving the attendance on solve it. After I say, then only give. Someone give the attendance in the chat. Okay, Suraj Bora. Please do not give the attendance. It won't be considered now. Okay, it will be considered after the class is over. You have to be present till then. Okay. So after that, yesterday we discussed the numerical. Was it not that clear for you? Hello, 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 students.
Yes, sir.
Yesterday we discussed the numerical, right? That mg cos theta sin theta. Is it clear for every one of you?
Yeah.
Should I explain it now? Clear now?
Add for other, I don't know, sir. For me, it's okay.
Yeah, it's okay now. Okay. Then others are not responding even. Fine, leave it. Okay, so let us now discuss this. So plane truss. What is plane truss? Just now we discussed the basic form of a truss is a triangle formed by three members joined. Okay, so for a basic structure of the truss, it will look somewhat like this: a simple triangle. Okay, so here is one support. So here is one support. So in this way, this is called basic truss. Now, if you look at this here, this is only one triangle, huh? And they are forming three joints. Here is one joint, here is other joint, and here is the other joint. So this is rigid. But then but then if if this triangle is joined by another triangle now. I'm just drawing it for illustration. And you just do one thing, you erase this one. Okay. So after that, we'll be putting the supports here. Right. So what will happen? Here is one support here and the other support is here. So eventually like this, in this manner, there can be large number of triangles. Yes or no? Just like this. And if the triangles are more, then this will be a more rigid system. So in this way, a simple truss can be drawn by combining a large number of triangles. Okay, so this is how a truss is defined. So here it is internally rigid. That means what? The structure is rigid, and and they are generally supported by three reaction components, as I show you beforehand. So in this way, so in this way, a truss can be defined as a structure that is made up of frames. Okay, if this is made up of frames, then this is a combination. Huh? And eventually, what happens is that these frames are joined together and they form a rigid structure. This is how we define a truss. So these are the examples we just discussed. This is a bridge truss, this is a roof truss, and here this is a triangle, combination of triangles. Okay, so these are known as truss members. Okay, and these are truss joints. Now look, now there is one important thing. Okay, even there will be certain, if a truss is designed, after that there will be definitely certain methods like how to analyze a truss, how to solve a truss, because you have to find out the member forces, the reaction forces, yes or no, everything, right? So how will you find out? So for that purpose, what happens? There are two methods. The methods is known as what? Method of joints and method of sections. So in these two methods, two methods, we'll find out the analysis. This is just a basic thing. Huh? If you see the huh? What happened? So this is the method of joints. So this is the method of joints. Can you see the slide, everyone?
Yes, sir.
Sir.
Okay. So in the method of joints, what you do? Wait. So what is basically the method of joints? Now in this method of joints, what happens is that look here. Suppose we are considering one particular joint here. Okay. So here it is joint B. So this joint is considered. Now for analyzing this joint, what you have to do is you have to find out this joint is connected as a triangle to these members. Look, here is joint B. B is connected to what? E. E is connected to D. And in between there is joint C, and here it is A and F. So here we have all these joints. So 1, 2, 3, 4, 5, 6. So we have got 6 joints, right? So now we have to find out what? First of all, you have to find out the individual forces. Now, for finding out the individual forces, we have to find out what? The reaction forces. We discussed regarding finding out reaction forces, right? In moments. Yes or no? Hello? Hello? Hello?
Yes, sir. What, sir?
Huh?
What, sir?
What, sir? Huh? Did you discuss the finding of
Reaction
the
of
reactions?
reaction force.
Did you discuss the finding out the reactions and finding out the moments? We discussed, right? Did you solve some numericals? Yes or no? Okay, keep it aside. We'll discuss again few numericals
Yes,
next
sir.
class. So now let us see. This is a joint. This is a joint. So in method of joints, what you need to do is you have to find out all the forces that are acting on that particular joint. Now, how will you find out the forces acting on a particular joint? Suppose this is a force. Suppose this is a joint B here. So here it is B. So that means what? You will you just have to find out which are the members. Look, this is BE. So this member is giving a pull from that side. So we have this BE. Similarly, we have BF in this side, right? Then we have BA or AB. That's it. And then from bottom, in bottom we have one force L that is acting. Okay. Now we have to consider all these members and eventually analyze. So this is a basic principle. Okay, just an introduction how to analyze. Now similarly, once you analyze this, you will be getting what? You can consider joint A. So in joint A, what you need to do? You have to find out the reaction forces R1, then this is AB and AF, right? So these two forces that are acting, you just need to find out. And eventually you will be using like this kind of principle. So eventually you will be able to solve it. Now for the other joints also, like joint C, if you see, joint C is what? Horizontal. There is no external force acting downwards. But then we have one perpendicular members here, and there are two members acting in the opposite directions. Now if a figure, you will find this kind of figures where there is one member only, there is no other members acting, this is perpendicular, then always remember this will be 0. After that, if you look at the edges or if you look at the top corners, suppose joint F, and this AF is giving one kind of pull here and other is here. So if you have to designate the directions how the pull and push is given, you just need to what? You just need to make the arrows right. Okay. Now here is one support. If there is a support here, so definitely here will be one reaction in this side and the other will be in this side. Okay. But then here there is one load, but there is no support like this. So it is like this. So basically you have to go make the arrow thing right. So here it will be like this. And here it will be somewhat like this. So here it will be 0. That's a different thing. Now everywhere you have to put the arrows like this. So once you put the arrows, once you put the arrows, then you will get two reactions. And considering each and every single joint that is present, A, C, B, F, E, and D. So we have to use analyze this truss. Okay, this is what method of joint is known as. Okay, so you just we will not solve numericals as it is not in the syllabus this time. I will get in the higher semesters for this. Okay, so what we will basically do is we will basically give you an overall overview. Now the second method that I told you we will discuss is method of sections. So in method of sections, what we do is we just what we do is we just there is a truss, suppose this is an overhanging truss. Now in order to analyze it, okay, in order to analyze it, we just consider certain sections. That means what? We cut this part into half. Now look here. In this kind of truss, this is a different form of truss. The supports are here and here. Which method you have to adopt? You will have to see according to the Truss figure. Then only you will be able to determine whether it will be method of section or method of joins. For being in method of joins, what you need to have, can you hear me, every one of you? Hello? Hello?
Sir. But sir,
Ah, but what? Temazar?
Spanish.
What happened, Temar? Hello?
No slides, sir. We don't see them. Now we can see slides, sir.
Gladys, you are able to see?
Yes.
So, what happens? There are two methods of section and method of joins, right? So, in method of joins, in structures where there are large number of these triangular things, so you can't just put a cross section here and then find out, because you have to analyze this part, oh sorry. So, you have to analyze every single part. So, you can't use method of section, but you can use method of joins because there are large number of joins. Now here if you see, if you put this thing like this, so what will happen, you can cut this part out, then you will find that there is one reaction here, then this one is giving one reaction for this member, for this member, and for this member. So you have only three reactions unknown, so you can find out these forces, and eventually you can find out and you can analyze the whole truss. So in this way, the two methods of analysis, that is method of section and method of joins, these are used. So these methods are basically applicable for truss analysis. Are you clear with all these things? So can one or two of you just give me some practical examples of a truss? Yeah, hello, hello.
Sir.
Can any one of you just give me a practical example of a truss?
Steel bridge, sir.
Steel bridge. So
Where
in a steel
technique
bridge,
of truss is used. Sir.
in steel bridge, what kind of analysis shall we do? Like,
It's
shall we use
join.
good, very good, joint. Now, where will you use method of sections analysis? In which kind of structures? Truss. Any idea?
Steel tower, sir.
Steel tower. Yeah,
Yeah.
tower will do, but then you have to see the actually there is not any predefined thing. Just you have to see the shape of the truss, right? You have to see the shape of the truss and then eventually what? Eventually analyze the truss. Okay, is it clear now? So this is how you will analyze
It means, sir, in
in a what? Uh, hello, hello, Temazat, I'm not hearing you.
yes, sir.
Mute your, yeah, say. You unmute yourself.
Sir.
Hmm. Say.
Sir.
Hmm. Say. I'm hearing.
That means we can use a method of join in method of section.
Hmm. Look, you can use method of joins, but these two methods are only dependent upon how easily you can find out the solutions, right? So these methods are that is why there are two methods. You can use method of join in this figure also, but then if you see the supports are here and here, right? So there are two supports, but then supports are not uniform. So the forces, reaction forces will be different. So here it will be one, here it will be one. But computing these two reaction forces will be a bit difficult for you people because they are at different elevations. They are not at the same elevations, or they are at different positions. But then here in this kind of process, what happens? You have one reaction force here always and one reaction force here always. So computing this one and this one will be much easier than this one and this one. That is why we prefer method of sections here. Are you getting now? Why we prefer method of sections here? So here it is a single truss thing. So look, and if you divide this into two parts here, by this, then this is symmetric. Like this part analysis and this part analysis will be both same because the shape is what? The shape is totally symmetric, right? Yes or no? The shape is totally symmetric like this. So that is why we use this method. Okay, is it clear now? Is it
Okay
clear?
for now, sir.
So what? Any doubt, everyone? Anyone? You can ask me for any doubts. No doubts now?
No doubts.
Okay, fine.